Hello, I'm Hong Kai, co-founder and CTO of Roceso Technologies. So Roceso Technology is a medical device company, spin-off from NUS, National University of Singapore, since year 2016. I'm a biomedical engineer by training, and I got my degree since year 2013. And then after that, I pursued my PhD degree and then got the degree from since year 2017. So the reason why I pursue my PhD degree was because during my final year project in my undergrad years, I managed to work with clinicians, and my professor was from biomedical engineering, and then he was working on a project with stroke related studies. So we were studying on how the patients walk after they suffer from a stroke. And that time, actually, my uncle was suffering from a stroke as well. So that actually inspired me to continue my PhD degree and work in biomedical engineering related field. And then because I think another reason is because during my year 4 of my study, I remember one of the professors say a doctor saved one patient, but a biomedical engineer saved all, because they managed to, if they manage to invent some medical devices that can actually benefit mankind. So during my first year of my PhD degree, my project was focusing more on how we can create devices for rehabilitation of stroke patients. So we look into a different aspect, for example, the upper limb rehabilitation and lower limb rehabilitations. And just nice that my professor, my supervisor, Professor Ray Yao, came back from Harvard. He actually had some idea on soft robotics. And then that was, the soft robotic field was actually relatively quite new at that time. And then we were brainstorming on like how we can use this soft robotic technology to help stroke patients, particularly in the rehabilitation field. And then at that time, then we actually consult our clinicians, and then we come up with some ideas on like how we can create robotic products such as a soft robotic glove and soft robotic socks that can actually help to move the patients, help the patients move, and for rehabilitations. And I decided to actually zoom in more onto the upper limb rehabilitation, particularly on the hand rehabilitation, and using the soft robotic technology to actually create a product that is more portable, lighter, and can be used at home for these stroke patients. So from then on, my PhD thesis was focusing more on how we can actually streamline the design of the actuators. So just to explain a little bit more on the actuators, actuators are something that moves, like our DC motors, stepper motors, or linear motors. Compared to the traditional robotic devices, we thought that the soft robotics can be more lightweight and can be more comfortable for patient use. So that's why during my PhD thesis, I focused a lot on the design of the soft actuators. To explain a little bit more on soft robotics, I'm not sure whether you guys have watched a Disney movie called Bear Max. So Bear Max is actually one of the examples of soft robotics, basically using a robot that are made of soft materials such as balloons or such as a fabric. So they are much more, I would say, more user-friendly and then cute. And then I will say that, like, for example, for the Bear Max, right, they are much more user-friendly, and then the people tends to attend to them rather than those traditional robots such as Iron Man. Okay, so during my PhD, so after we develop the prototype, and then we think that it's best to actually spin off a company to commercialize prototype that developed in a research lab, because actually my professor told me that a lot of prototypes, if there's no one drive the prototype and then spin out and then to commercialize the product, it will always stay in the lab. So that's why he actually encouraged me and all the colleagues in the lab to join some courses or some programs such as a Lean Launchpad programs, or the tech launch programs to actually introduce our technology to people that are more experienced in the business aspect, and then we can form a team and then launch a project together and then learn all the skill sets, all the typical skill set, like for example the finance projections, regulatory aspect of manufacturing from the courses, and then after one of the most important one is to actually validate the applications to see whether actually our product actually is what the market wants. So at that time, I brought the technology to the course, which is a tech launch during my second year, and then that's how I met the co-founder, my co-founder Jen Wang, and then so we formed a team together with a few other students at that time, and then actually basically during the course we actually we actually interview a lot of potential customers in order to validate our technology, our products, and then to ensure that this is what the customer want. And then after the course, we are actually quite confident that this product is able to help a lot of patients, and that's why we actually launched the company together with my supervisor. So 3 of us founded a company, and then and we actually joined. After we formed the company, all of us were not full-time yet. So we actually joined a lot of other programs, such as a Lean Launchpad programs, and interview more people. And then and at that time, there was another program called a Jumpstart program, which is the medical device commercialization program. And that one was actually, I would say that it's one of the very important course for program for us, because they taught us a lot more on how to launch a successful medical device company. And of course, one of the most important one is actually to ask us to continue interview more potential users, and of course equip us with skill sets such as quality management systems, and told us the regulatory pathway is that they told us what do we need to take note on, and additionally there are some others like aspect like financial fundraising and some other skill set that they are not teaching us. They just told us that you have to take care of this when you form a company. And then of course from the manufacturing perspective, there are like a lot of standards and a lot of like device standards, and also pathway for us to actually to launch a product, to introduce a new product, which is called NPI, new product introductions. And then yeah, so in terms of skill set, I will say that there is no major shift in skill set compared to what I did in my PhD. For example, like critical thinking, literature review, and problem solving, which are, I mean, a common skill set that is still relevant as of now. But I would say that there were additional skill set that are required, like something that I mentioned just now, like regulatory pathway, QMS, even the leadership, and how we manage the people that like the outsourced teams, outsourced project partners, and also the internal members. Yeah. So when we actually try to commercialize this product, right, and at that time, I will say that we were a bit naive, because we thought that, okay, this prototype we can already sell without actually knowing a lot on the regulatory perspective, and then we have to pass so many tests in order to commercialize a medical device. So I will say that during my PhD year, once we define a few problems to solve, we actually can focus a lot, like very deeply in the problems, and then how can we solve that. But when I actually start to run a company, right, there are many aspects to take note on. Especially now, we are still a very lean company, and then we need to take care of, like for me, I will need to take care of, other than the product development, I will need to take care of the engineering operations, supplier management. Yeah, so I mean, these two are actually yeah, engineering operation and productions, and sometimes these tasks can be quite tedious, and then at the beginning it actually can be quite challenging as a fresh, I would say a fresh grad from PhD, because during your PhD you were really focusing more on the technological aspect, but right now there are much more like inventory management, for example. Even I have to personally go down to those test labs to test and verify against those standards. So these are some new challenges, I would say, at the beginning. But right now, once we are actually much more used to this kind of environment, used to those typical pathway for commercialization. So right now are much more, I would say, yeah, I am able to handle this one right now. Yeah, so personally, I really believe in STEM education because I came from STEM education as well. So I believe that the next technology breakthrough will actually come from people that are trained in STEM education. I mean, you can see the past examples. There are many new invention, new technology like LED light, silicon semiconductor aspect. They are actually also come from invented by people from trained in STEM education. Yeah, so STEM education actually really prepare us and train us with very critical, a lot of skill sets such as the critical thinking, problem solving, and also be creative. And then these are very important to me even right now. And I would think that even this skill set that you got it from the STEM education will benefit you not only in the STEM related career, but also the non-STEM related career. So for example, one example I can give you is a lot of my course mates during my biomedical engineering degree, because they are trained in logical thinking. So they are actually very highly, I would say, highly sourced from industry that are non-STEM related. For example, finance or banking. So all these banks, they try to recruit engineers for them to actually to develop their software, back end, something like that. So I will say that once you pursue STEM educations, right, as a person, you can think more logically, and then be more creative. And this is very useful in your not only in your work, also in your daily life. Now I'm going to show you two products from our company. The first one is called Exo Glove, and the second one is called Signing Sense Motion. And the Exo Glove is actually the products that we actually commercialize and using the technology developed in NUS. And then after that, after we license out the patents from the NUS, that we continue to develop this and make it into a product. So during my PhD, I was focusing mainly on the one that inside, which is, we call it soft actuator, something that is moving. And later I will show you how it moves. And then what I did during my PhD was to how can we streamline, how can we use less air, less battery to actually power this glove so that it can be lighter, and then for patient use it will be much more comfortable. So later I'm going to show you how it moves, and then before I wear it, and then show how this glove can help my hand to pick up objects for rehabilitation purpose. So later you will see this glove start to close and start to open. Yep, so now it's closing, and then the soft actuator inside, once it's being pumped, and then it's actually closed, and then now it's extend and do opening. So basically for these actions, right, it's actually create a force to help the patients to move their hand. So imagine this glove is like an additional therapist that's sitting beside you to help you to move your hand. So this is how this glove is doing. So it's completely made of fabric, and we are not creating Iron Man, we're actually creating, I think, a fabric glove. So another one of the unique selling point of these gloves, right, is that we can control individual fingers. So I'm going to show you how this glove moves, like how each fingers moves. Yeah, so it's starting with the thumb, and this exercise is particularly useful for to train patients with fine motor movements. Once they are slightly recovered, now they require much more training on the fine motor movements. So this one will be much more useful. So it's actually pre-programmed, so we can control the speeds and the force. And then, like for example, if you want to be faster, slower, depends on the patient's condition. And then this we can pre-program. And then the therapist can actually check the condition of the patients and then adjust accordingly. Yep. So recently we also developed a new training method. We call it mirror therapy. Basically, use your healthy side of the hand to control these gloves. So basically, how this features was actually recommended by a lot of our customers, and then through our customer validations and interviews, and that's why we actually incorporate it in our recent software. So now I will show you one. How do I control? So to control it, I'm using a camera. So this camera can capture my hand movements, and I manage to, then the system will actually activate this glove according to my hand movements. Okay, so it detects my left hand. I'm controlling this glove, which is the right hand. Okay, yeah. So closing. Okay. Opening. Okay, thumb down, thumb up, index finger down. Yeah. So basically it replicates my movements, like for example, like pinching. So we do these two actions, and then we can do like three fingers pinching, which is called tripod pinch. Yep. Yep. So basically this training was actually recommended by our customer. So that's why it's actually, you can see here, it's very important to always constantly engage to our potential customers or our existing customers, because they can actually give a lot of feedback to us to actually improve our products. So right now I'm going to wear this glove, and show how this glove is help me to actually move and grip some stuff. So I will need to wear this wrist strap first to actually stabilize my wrist, and also it serves as an interface between the gloves and my hand. Okay. So I'm showing you one of the training mode, which is called functional task training. And this training is extremely important for patients, because the patient they can interact with the real objects in their daily lives, and then give them some sensation on their palm. Yeah, so I'm showing the level 1, which is to gripping a ball or an apple from a bowl, and then move their elbow and move their shoulder. So even though they cannot move, or they can move a little bit, the glove can actually help them create some force that is enough for them to grip these objects. Okay, so this is the object, for example. So I'm not moving, so the glove actually helping me to grip. Yep. So I can then try to move my arm. Okay, now it's releasing. Yep. So it actually depends on the patient condition. We might not need to actually follow the video exactly. So for example, I can actually ask the patients to lift up and put down instead of moving left and right. Yeah. Okay. And of course, with this function, we can actually also train fine motor control. What it means is actually like for example, pinching actions that require the patients to actually move 2 fingers instead of all 5 fingers. A lot of patients, when they first start training, right, they start with this kind of gross movements, gross action, basically, which means they try to close all fingers at once. Once they recover, they can actually start training on those fine motor control. So right now it's the level 5, which is to pinching some cubes. helping me to pinch this thing. I'm not moving myself, and then it helps to try to open up. Yep. Okay. Yeah, so that's all for the demo of Exo Glove. And then since we formed the company, right, then we constantly receive feedback from customers, and we see different patient group. So for Exo Glove, it's particularly useful for patients that are, I would say acute patients. Basically means they just first suffer from the stroke, and then their hand is, we call flaccid, like cannot move. And then because this glove will be actually particularly useful for them to do the rehab, because normally people will say that the golden period of recovery after you suffer from a stroke is 6 months. So they have to train as early as possible. And then for chronic patients, like for example, those patients that already have, or elderly, they already have some movements. That's why we developed a new product called Signing Sense Motions. Okay, so now I'm demonstrating our one of the new product from our company, which is called Signing Sense Motions. So it's a software-based digital health products, and then it's particularly useful for patients that already have some residual movements. They can close, they can open, and now the therapists need to actually encourage them to move more, and then to practice more, so that we actually incorporate gaming inside this software, so that they can actually much more motivated to move their hand or even their forearm even more. So now I'm using my left hand, and then putting on top of this camera, and then by moving my hand, and then the software can actually detect my movement, and then we can start to play games. So right now I'm showing a few games that to train the hand, wrist, and even the forearm. So I will start with closing, opening, and even playing the piano with individual fingers training, and also something like turning a knob using the wrist motions. And of course, for the forearm, I will do we call supination, like moving like on these positions, pronation, supination, and even I will say left and right, and also reaching. So these are 6 games that I'm going to show you later. Yeah. So let's start. So if I hit a bomb, then I have 3 chances to avoid the bomb. Closing is going down, and opening the hand is going up. Yep. So I will skip this and then go to the piano games. So with this, I need to move my thumb down. Yep. And this one is the wrist turning. We call ulnar deviation. So basically, I need to turn and then pick up the diamond or some stones. So and then you can see here there's a countdown, and there's a score over here, so that the patients can be more motivated and to hit higher score and higher score. Okay, so this one is a supination. Basically, I need to turn my wrist to actually catch the ball. It's a very simple game, but actually it encourages the patients to move a little bit more. Yep. Of course, I can adjust the sensitivity over here. Higher means I have to turn a little bit more to capture, go back. Lower means I just need to turn a little bit, it will go there to capture. Yep. And then of course, left and right. There is a real avatar over here, the hand avatar, to actually let the patient to see their hand. Of course, they can see the hand here. And the last one, which is our the favorite game for our patient favorite actually. So basically, is to move backwards and then move forwards. So we have a lot of we call auditory feedback to actually encourage the patients to actually move more. Yep. Yep. So towards the end, then we have a summary page to summarize the patient scores, like how much they score for each games, and then the therapist can actually examine the score, and then you can see like this patient score 92 points, and then we see like over different period, over several days, whether they are improving or not. Yep. Yeah, that's all for the demonstration today.